142. Okay, that's so 142. What's for the graduating seniors? The graduating seniors and ours. Both. Okay. 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 6 to 8. 313. All right. All right.
6 to 8.
Yeah, 6 to 8. Yeah. No, I said this. You said AM.
Oh yeah.
Yeah, 6 to 8 p.m. So, you got to adjust your schedule. Whatever. No, James. All right. All right.
Listen to the audio. It wasn't that fucking bad. Nigga scrapped his nigga fucking old shit.
Kind of molecular motion having most to do with temperature. It's what?
Rotation?
Rotation.
Nah, that ain't it.
Internal vibrational motion. Oh.
Absolute zero corresponds to a temperature of.
B. It's both, actually, C. That's the same thing. It's B. I mean, C.
See?
Yeah, it's C. U.
This is just tricky.
You ain't like the human temperature, 97 degrees or something like that. When you check the temperature and all that. So it's C. It's gotta be C.
Oh, wait. Well,
Okay.
I was reading Celsius anyway. It didn't say calories.
So a calorie and a joule are the same, or they can have the same units, right? A red hot thumbtack, meaning it's so hot that it's turned red.
So big.
I would guess B.
Why would you guess B?
I just did half before. Or would it be double?
No.
It seemed here, half of it here.
So would it be A?
Okay, B.
Just C?
They boil at the same.
I'm gonna go see
I'm gonna go B. I'm gonna go B. This makes sense.
Because the boiling point is the same.
What's the question? I got a question. So, if you put your hand in 1 liter of boiling water versus 2 liters of boiling water, it's gonna burn the same?
Is it gonna burn the same?
Yeah, because it's the same temperature, so it's the same heat.
It's just one gonna burn higher and one not gonna burn higher, like on your arm.
Yeah. It's just a dip. Like, yeah.
Yeah, I mean, I'm not sure what you're asking me though. Is it
Yeah.
gonna
So
burn
they
the
both
same?
gonna be hot. Like that's what I'm saying. Like the 2 liters of
If
boiling
it's
water.
at the same temperature,
Yeah.
yeah, it's gonna be the same. Your arms is gonna go deeper in the 2 liters versus it stop at your wrist.
So why isn't the thermal energy the same as well?
Because I think it has something to do with both. Let's see, average kinetic and the molecule the same, which means yeah, that's how you get that answer. But for the thermal energy, I would say because it has obviously you have more water, right? 2 liters versus 1 liter. So I would say it has something to do with the heat capacity. And if so in 2 liters of water, right? 2 liters of water, even though they're holding or they both at the same temperature, right? 2 liters of water would hold more thermal energy because there's more molecules,
Yeah.
right? But the temperature is the same because of what they say, right? They both was boiling. So the temperature is the same, right? Temperature is, remember what temperature is? Temperature is the absence of heat, right? That's what temperature is, the absence of heat. Well, you know what I'm saying. So, right, whatever if you don't have heat, then it just means something is colder, right? So, but with thermal energy, right, it has to do with the particles inside. Remember how we talked about, the first question was what? Something about the translational motion of the particles. So that's what my, that's what I would come up with for why it wouldn't be thermal energy. Because there's more water in 2 liters, right? Even though they're at the same temperature. Say C? I heard somebody say C. Hey, what is the first law of thermodynamics? Was that a good guess?
Flows
It's
to
not
or
more
from
business.
Huh?
Heat loss equals the amount of heat transfer.
Say it again?
Heat loss equals the amount of heat transfer. So like energy is never
Created or destroyed.
Eight.
Right? Second law, hot to cold. Always hot to cold, never cold to hot. Good. You say C? Right, so, trying to think of stuff. It's kind of like what happens in your, in the piston in the car, right? Right, when the piston compresses the air, well, in the car it'll be gas, right? But in this case it'll be air, right? Then we know that when we change the volume, if you compress it, you're making the volume smaller, right? And so by Boyle's law, then we know that if we compress air, right, then the temperature goes up. Okay?
I really feel like it's B.
I don't really understand this question.
I think it's B.
You think it's B? Why? Because you recognize that word?
Yeah, we talked about that last week.
See? High quality. I don't know what they mean by high quality energy. I guess. I don't know. Low, dirty energy? Like dirty gas? I don't know what high quality energy to lower quality energy means. Alright. Say that water has a high specific heat capacity. There we go. There we go. Everybody gonna get this one though.
Hey. What?
Hey.
What does C even mean? Thermal inertia.
If you in the class, I'm just kidding.
Thermal inertia.
'Cause we
What
were-
does inertia mean?
Inertia is like inertia is what stops an object from like it keeps an object at rest pretty much.
Or what makes an object
Keep going.
move,
Yeah.
right? So thermal inertia would be what? Would be using heat to make something move.
Okay.
Has a lot of thermal inertia. So when something has a high inertia, what does that mean? What things have high inertia? Going back to what we learned in chapter 1 or 2, right? Huh?
High inertia, like massive objects?
Massive objects, right?
Mhm.
So then they have a high inertia, so they require more inertia, right? So something that has a high thermal inertia, right, means that they require more heat
Okay.
to move the molecules. That's why it has a high heat capacity. It can accept a lot of heat because the molecules have high thermal inertia.
Okay, so heat capacity and thermal inertia are like directly related.
Yes, oh yeah, sure.
So if you have low specific heat capacity, you have low thermal inertia.
I mean, that's logical.
Okay.
It's a logical way to look at it. I mean, of course, in science, not everything is that cut and dry. So, you know, but yes, that's a logical way to look at it, yes.
Okay.
And that's essentially, all of these are really saying the same thing, right? Right? Requires a lot of energy, just like what we just said, it requires a lot of energy to increase the temperature. So you increase the temperature by getting the molecules to do what? Move. Right? And once I get my water up to boiling, right? When I let it cool down, and it's going to give off a lot of energy because it did what? Accepted a lot of energy to get to boiling, right? So it's going to give off a lot when it cools. So all of these are essentially the same thing, right? Excuse me. Good. And somebody hit one of them lights back there for me, just so the video don't be all blurry. There we go.
Because it has less.
Heat capacity means it takes more heat to actually make it increase. So it means copper does less. I say copper.
Is that what everybody said? Might I say something different? So everybody agree with that, what he said?
Yeah.
All right, cool. Of course. They have lower extremes. So what does that mean? Lower extremes. Well, it means that it doesn't, or from what I'm understanding, I guess it means that it doesn't change that much, right?
Sometimes. Well, it only rains like sometimes in Hawaii, but it's normally like pretty temperate, right?
Yes, and don't really change.
That's bipolar.
answered this one already.
No,
I
I'm
really
reading the
don't.
question, I didn't read about 5 times.
I'm gonna guess. See, D, maybe.
Wait, concrete. See?
That's what I said.
Yeah. That's why you said, come on.
It
What
just-
is
it's just
thermal
simple.
expansion? I thought we went over
Yeah, the
talked about
concrete
it.
expansion.
You put down the
Yeah, we
concrete,
talked
so
about
it's
that.
steel.
Yeah. And where would you likely see steel? Which one of these materials would replace steel more likely?
Concrete.
Concrete, obviously. Right?
A.
Yeah.
I wanna say it's B.
You said D.
And I said B.
Oh,
Yeah,
I was
don't
gonna
play
say,
with me.
what
Don't play with me, man.
You said that why?
Yeah, that's why I said A.
Yeah.
It'd be like,
Right. Yeah.
but I never paid attention to them being shorter when it's cold.
Yeah.
Well, I mean, that's expansion though, right? Thermal expansion. Right? And now you're seeing, right, I guess now, you see a lot of the telephone stuff go to fiber, right? Fiber and that stuff is a lot of times under the ground, right? So. I wonder what they might have been made of copper. Telephone lines, the first telephone line, probably were made of copper. Right. Here we go, bimetallic strip. Now what device works based on that bimetallic strip?
Nebraska.
The air conditioner, your thermostat.
Or C.
Right? So an alloy is like a mixture. Yeah. An alloy is a mixture of two metals. That's what an alloy is. But a bimetallic strip is just two metals, two strips of metal on top of each other. Pretty obvious, right? Microscopic slush.
How? Could you explain that? Like, how does that make it less dense?
Oh, because ice.
Okay.
Ice is,
Oh, that's what they mean by microscopic.
yeah, ice is less dense than water, right?
Yeah, I was thinking like microbacteria and all that. Like I wasn't thinking like ice.
Mm-mm.
Okay, that makes sense.
Microscopically means bacteria.
Yeah.
Hey,
Alright. Water at 4 degrees C.
Slightly warm.
That's a trick question. Excuse me. So it contracts. The sample of 0 degrees water, so it's frozen. Is that right?
So it's
So-
gonna expand.
So if I heat ice, it's gonna go to water, right? And so, water is more dense than ice, right? So then that means that the volume is less, because it's more dense. Density equals mass over volume. So if volume is on the bottom of my fraction, so if I decrease volume, I increase density. You see that? Alright. So that's why it contracts, because the volume is small. I went the wrong way?
No, it was just a different question.
Oh, shucks. Well, we missed it. We about to be finished with this. It expands when it is heated.
Interesting. Wait, what? I'm not getting it.
Yeah, I don't know why, I don't understand the point of this question.
D? Okay.
Oh, that's it? Alright, y'all, that's it. So what we'll do on Wednesday is we will review chapters 4, 5, and 6. Then Friday, your exam will open up. And I'm gonna get the test grade, I know I keep saying that. Friday? Well, right now we do, okay? But I'll let you know on Wednesday if we don't.
You got that. I'm saying, like, we still gotta go over like